Welcome to our channel Easy Physics and Mathematics. We are discussing CBSE 8th class portion, that is force and pressure. In last class we have discussed what is force and types of force, effects of force, etc. Today we are going to discuss about a very important portion, that is pressure. What is pressure, factors affecting pressure, applications and consequences of pressure in our day-to-day life. Okay, we will start our lesson, that is pressure. What is pressure? Pressure means force exerted per unit area. Okay, pressure means force exerted per unit area. Okay, we are taking an area like this and we are applying a force on it. In this area, how much force we are applying? Okay, in this given area, how much force we are applying, that is called what? Pressure. Understood? Force exerted per unit area, that is pressure. Okay, we are taking an area, that is A. We are applying a force F. Then how much force we are applying in that given area, that is called pressure. So we can write like this, P. We are representing pressure with the letter P. So P is equal to F by A. That is force per unit area. That is called pressure. Okay. Then next, factors affecting pressure. Which are the depending factors of pressure? First factor, we say that how much force we are applying in a given area, that is called pressure. So, okay, from this equation we can say the depending factors of pressure. First factor is what? Force. Pressure is directly proportional to force. So, first factor is force. If force increases, pressure also increases. If we are applying high amount of force in this area, the pressure also high. If directly proportional, this symbol means directly proportional. The meaning of directly proportional means if one physical quantity increases, another quantity also increases. That is the meaning of directly proportional. Okay, if pressure increases or if force increases, pressure also increases. So this is the first depending factor of pressure, that is force. Okay, second one is, which one? Area. Okay, force, pressure inversely proportional to area. Okay, pressure inversely proportional, that means reciprocal we are taking. That is the meaning of inversely proportional. Okay, pressure is inversely proportional to area. Inversely proportional means if a physical quantity, if a quantity increases, another quantity decreases. If area is high, pressure is less. If area is less, pressure is high. That is the meaning of inversely proportional. So these two quantities are the depending factors of pressure. First one is force and second one is area. Okay, by combining these two, this is the first equation and this is the second one. By combining these two equations, we will get pressure is proportional to F by A. Pressure is directly proportional to force and pressure is inversely proportional to area. This is the proportionality sign. We know that this is proportionality sign. To remove this proportionality sign, we need to introduce a constant. Okay, we need a formula, we need an equation. So we need equal sign, is it? So to remove this proportionality sign, we will introduce a constant. So P is equal to, pressure is equal to, here we are taking a constant K into F by A. Okay. To remove this proportionality sign, we are introducing a constant, that is K. Then this proportionality sign will change into equal sign. So P is equal to K into F by A. In this pressure equation, we are taking the value of K is 1. K is equal to 1. So this equation will change like this. P is equal to 1 into F by A. So P is equal to F by A. This is the equation of pressure. Understood? So there are two depending factors for pressure. First one is force and second one is area. How force depending the pressure? Force increases, pressure also increases. If force decreases, pressure decreases. Area means if so much area, that means area is high. Area is high, pressure is low. That is inversely proportional. If so much area, the pressure is high, less. Okay. Area increases, pressure decreases. By clubbing these two equations, we will get P is proportional to force by area. To remove the proportionality sign, we are introducing a constant, that is K. So P is equal to, here the value of K is 1. So P is equal to 1 into F by A and P is equal to F by A. So we got the equation of pressure. P is equal to force divided by area. Okay. Next is unit. Unit of pressure. The pressure unit is, equation is what? P is equal to F by A. So force unit is what? Newton. We know that. Newton is the unit of force and the unit of area is meter square. So the unit of pressure is Newton per meter square, otherwise we can say Pascal. Okay, the unit of pressure is Pascal. Understood? So the unit of pressure is Pascal. How Pascal will come? The unit of pressure, force is Newton and area is meter square. So Newton per meter square, otherwise Pascal. Next, if 1 Pascal means 1 Newton per 1 meter square. That is, if the area is 1 meter square and we are applying force is 1 Newton. We are applying 1 Newton force in 1 meter square area, then that pressure is 1 Pascal. Understood? 1 Pascal means if we are applying 1 Newton force in 1 meter square area, that is called 1 Pascal. Okay. These are the main topics or basics of pressure. Next is applications of pressure, the consequences of pressure in our day-to-day life. First one is sharp nail hammer very easily. We know that the end of the nail is very thin. Thin means what? The thin means area is very less. We know pressure and area is inversely proportional. If area is less, pressure is high. Area is less, pressure is high. The nail end area is very less. So the pressure of the end of this nail is high. So it can penetrate very easily into the wall. Okay, why sharp nail hammer very easily? The end of the nail area is very less. If area is less, pressure is high. Force is high, pressure is high. So it can move very easily into our wall. Understand? Second one, why strap of school bag? We know that the strap of the school bag, area of the strap of the school bag is high. Why this area is high? Strap of the bag area is narrow. What will happen if area less, pressure increases? So much pressure we felt. So the area is high, pressure will decrease. The effect of the pressure will decrease. So we are using wide strap school bag. Understood? We are using wide strap of school bag. Why? If area increases, pressure will decrease. Area and pressure is inversely proportional. If wide strap we are using, the pressure is less. Okay. Understood? Second one, sharp knife cut easily. In our kitchen we are using sharp knife instead of blunt knife. Why? The sharp knife, the end of the knife is sharp. This is cutting end. Okay. This end of the area of this end is less. If area is less, pressure is high. If area is less, pressure is high. So we can cut or peel the vegetables very easily. Understand? If area is less, pressure is high. Area is inversely proportional to pressure. So we can cut or peel the vegetables very easily. So we are using sharp knife to cut vegetables. Why we are using sharp knife? The end of the sharp knife is area is less. So high pressure. So we can cut very easily. Okay. Fourth one, pencil heels can't walk through sandy floor. If we are walking along a sandy floor, we are using broad shoes. Why? Why we are not using pencil heels? If we are using pencil heels like this, this is heel, is it? This is the end of the heel. Here, pencil heels, area is less. So, what will happen in pressure? Pressure increases. If pressure increases, this heels will enter into the sand very fastly. It will penetrate into the sand very fastly. So we can't move smoothly through the sand. So we are using broad shoes for walking along the sand. Okay. So pencil heels can't walk through sandy floor. Why? In pencil heels, area is less. If area is less, pressure is high. Okay. So it will penetrate into the sand. So we can't walk along the sandy floor smoothly. Understood? So these are the some examples of pressure in our day-to-day life. First one, sharp nail hammer easily. Second one, wide strap of school bag. If strap area increases, pressure decreases. Sharp knife cut very easily. Fourth one, pencil heels can't walk through the sandy floor. Okay. Our next portion is fluids. What is meant by fluids? How pressure affected in fluids. Fluids means the substances which can able to flow. The substances, those are able to flow, that is called the fluids. Examples. We know states of matter. We know which are the states of matter? Solid, liquid, mainly solid, liquid and gases are the states of matter. What are the specialities of solids, liquid and gas? What are the arrangement of atoms? In solids, the atoms are tightly packed. Is it? Like this. Solids are tightly packed. So, which can't to flow. Can't flow. Then liquids. In liquids, some distance between the atoms. It can able to flow. It can flow. Next is what? Gas. The intermolecular distance is very high in gaseous molecules, gases. So, it can move very easily. So, we can say that the examples of fluids are liquids and gas. Why? Liquids and gases are able to flow. So, liquids and gases are fluids. Understood? Fluids mean the substances which can be able to flow. Examples are liquids and gases. Next is fluid pressure. Fluid pressure. From the word itself, we can say what is meant by fluid pressure. Fluid pressure means the pressure exerted by fluids. Okay, the pressure exerted by fluids. Which are the fluids? Liquids and gases. So, fluid pressure means what? The pressure exerted by liquids and gases are is fluid pressure. Understood? The pressure by fluids. Pressure by fluids. That is fluid pressure. Next, properties of fluid pressure. Which are the properties, okay, of fluid pressure? We studied what is fluids and what are the examples of fluids. Next, what are the examples of fluids? Next, we are going to study fluid pressure, properties of fluid pressure. So, first property is if pressure increases with depth. Okay, that means if depth increases, pressure increases. Okay, we are taking an example. This is a container filled with water. This is a point A and this is a point B. The pressure is high in the point B. Why? If depth increases, pressure also increases. This is the first property of fluid pressure. If depth increases, pressure also increases. We know that the persons working in submarines using some special types of dresses, is it? Why they are using like that? To equalize the pressure inside the body and water. Inside the body there is blood. Blood is also fluid. So to equalize the pressure they are using like that. So we can say that pressure increases with depth. Depth increases, the fluid pressure also increases. Next one is pressure decreases with the height. That is, height increases, pressure decreases. Height increases, pressure decreases. Okay, this is a mountain. This is a mountain. A person is climbing along this mountain. Okay, we know that they are using some oxygen cylinders, is it? Why they are using oxygen cylinders? If height increases, pressure decreases, then some respiration problems will affect them. So, to reduce that suffocation, that respiration problems, they are using that oxygen cylinders. Why? The height increases, pressure will decrease. Okay, if the height increases, here the pressure is very low. So, height increases, pressure decreases. This is the second property of fluid pressure. Understood? Third one is pressure equally transmitted in all directions. Okay, here we are taking a vessel and fluid is here, water is here. We are applying a force or pressure here. This pressure will transmitted in all directions. Otherwise we can say that if we are putting some holes like this, through all holes the water will transmit. Why? The pressure is transmitted equally in all directions. So if we are applying a pressure on water or fluid, that pressure will transmit it in all directions. Understood? This is the third property of fluids. Fluid pressure. So first property, pressure increases with depth. Okay, next. And we are taking an example. A vessel filled with water. We are putting 3 holes in it. Okay, this is the first hole, and this is the second hole, and this is the third hole. Hole A, hole B, and hole C. Through the hole C, the water will move very fastly. In high pressure, the water will move in outside, but through hole B, the water moves like this. Through hole C, the water will move like this. Why? If depth increases in C, the point C, the pressure is very high. This is hole C, and this is B, and this is A. Through hole C, the pressure is very high, so it can flow very fastly. And through hole B, in moderate mode. Why? This is in between A and C. So it is in moderate mode, the water will flow, and through hole A, very slowly water will flow. Why? The pressure is very less in hole A. Understood? So this pressure increases with the depth. If depth increases, pressure increases. Second one, pressure decreases with height. Height increases, pressure will decrease. If height increases, pressure will decrease. Third one, pressure equally transmitted in all directions. If we are applying pressure on a fluid, that pressure will transmit equally in all directions. Understood? These are the 3 properties of fluids. These are the 3 properties of fluid pressure. Again, one more thing, to measure fluid properties, we are using an instrument, that is manometer. Okay, by using the instrument manometer, we can measure fluid pressure. Okay, next small topic, that is atmospheric pressure. Atmospheric pressure. Then what is atmosphere? We know in our earth has atmosphere, is it? The envelope of air, that is called the atmosphere. Atmosphere means what? Envelope of air. Atmosphere is the envelope of air, that is called the atmosphere. Atmospheric pressure means what? The pressure exerted by the atmosphere, that is called the atmospheric pressure. In our earth has so many layers, troposphere, stratosphere, mesosphere, all things we know that will exert the pressure on the earth. So that pressure is called the atmospheric pressure. Understood? Atmospheric pressure means what is the pressure exerted by the atmosphere, that is atmospheric pressure. The atmospheric pressure also we can measure by using barometer. The fluid pressure we can measure by using manometer, and atmospheric pressure by using an instrument, that is called a barometer. So today we discussed what is pressure. Pressure means the force exerted per unit area. What is the equation for pressure? Pressure is equal to F by A, and unit is Pascal. Properties of pressure. Next is applications of pressure in our day-to-day, otherwise consequences of pressure in your day-to-day life. I hope you all understood all things. And what is fluids and what is the properties of fluid pressure? What is fluid pressure? The pressure exerted by fluids, that is fluid pressure. And properties of fluids means if depth increases, pressure also increases, height increases, pressure decreases, and pressure equally transmitted in all directions. That is the three properties of fluids. Atmospheric pressure also we studied. What is atmospheric pressure? Pressure exerted by atmosphere. These all about today. I hope you all understand all the portions. If you like your channel and videos, subscribe our channel and enable the bell icon. Then you will get the notifications of our classes. Thank you.